Europe's genetic history seems mapped and explained, until you look at the Basques. Their DNA doesn't fit any migration story, resisting the great Indo-European wave that rewrote the continent. Scientists expected answers, but found a relic, the highest rate of Rh-negative blood anywhere, and ancient genes untouched for thousands of years. Why are the Basques so different? The search for their origins may overturn everything we thought we knew about who first called Europe home. During the last ice age, when glaciers pressed down on much of Europe, a small region nestled between the Pyrenees Mountains and the Bay of Biscay became a rare sanctuary. Here, ancient people found shelter in limestone caves, their lives unfolding in the flickering light of hearth fires. The walls of these caves still hold the marks of their passing, bison and deer painted with ochre and charcoal, some over 30,000 years old. These images, preserved in places like Icaen and Saint-Mamin, are among the oldest in Europe, testifying to an unbroken human presence stretching from at least 36,000 years before present through the end of the last glacial period. As the ice retreated, this region remained a crossroads for survival. The land's unique climate, milder and wetter than the frozen plains to the north, allowed small bands of hunter-gatherers to persist while other groups vanished or moved on. Genetic clues from ancient remains reveal a remarkable story. The people of this region carry traces of Neanderthal ancestry, about 2 to 3%, a legacy shared by all non-African humans but preserved here through continuous occupation. Radiometric dating of bones and artifacts confirms that these communities never fully disappeared, even as the rest of Europe emptied and refilled with each swing of the climate. Archaeologist Dr. Conchi de la Rua, who has spent decades excavating sites like El Portalón in Atapuerca, describes the region as a refuge for human diversity. Her team's work has uncovered evidence of enduring genetic lineages, connecting the dots from Ice Age artists to the first farmers and beyond. The Basque country's caves, valleys, and forests provided not just shelter, but a cradle for a population that would remain distinct as wave after wave of newcomers transformed the rest of the continent. In these ancient shelters, the roots of the Basque genetic mystery began to take hold, setting the stage for a story of survival and separation that would last thousands of years. Around 6,000 years ago, the hills and valleys of the Basque country saw a quiet but profound transformation. Newcomers arrived from the east, bringing with them the seeds and animals of the first European farms. These early Anatolian farmers settled alongside the region's hunter-gatherers, introducing wheat, barley, and sheep to a land still shaped by the memory of Ice Age survival. Archaeological digs in sites like El Portalón have turned up polished stone axes, charred grains, and fragments of pottery, evidence of a changing way of life, but not of a total upheaval. Genetic studies reveal that this shift was not a story of conquest or replacement, but of fusion. The DNA of modern Basques carries a strong signal from these Neolithic farmers. About 70% of their ancestry traces back to this migration. Yet, the genetic imprint of the earlier hunter-gatherers was never erased. Instead, it lingers in rare maternal lineages, such as haplogroups H1J1 and H3C2A, found at high frequencies in Basque populations today. These genetic signatures are like threads connecting present-day families to ancestors who painted bison on cave walls and fished in Ice Age rivers. This blend of old and new created a unique population. While much of Europe saw repeated waves of migration, the Basque region absorbed the Neolithic newcomers without losing its ancient core. Marriage patterns and small, stable communities help preserve this genetic mix. Over generations, the Basques became a living record of Europe's first great fusion, the meeting of forager and farmer, survival and settlement. Their DNA, shaped by both inheritance and adaptation, set the baseline for what would later become one of the continent's most enduring mysteries. As the rest of Europe braced for the next great upheaval, the Basques held onto a genetic identity that was already ancient, yet unmistakably their own. In the folds of the Pyrenees, entire villages once counted their kin by the dozens, not the hundreds. Family names repeated across generations, and marriage outside the valley was so rare that local priests could trace nearly every union through parish registers dating back centuries. In AIA, a small shepherding community, blood surveys in the mid-20th century uncovered a startling genetic pattern. Nearly 70% of one family line tested Rh negative, a blood type found in less than 16% of the broader European population. This anomaly wasn't isolated. Across rural Basque valleys, researchers found Rh negative rates far exceeding those of neighboring regions. Such patterns didn't happen by chance. For centuries, strict social customs and the geography of the land kept outsiders at bay. The mountains acted as natural walls, but the real barriers were woven into daily life. Marriage records from 1500 to 1900 reveal endogamy rates above 80% in some rural parishes, meaning 4 out of 5 marriages joined people from the same community. In some valleys, church rules imposed fines on those who married outsiders, and local councils enforced these unwritten laws to protect family estates and language. The effect was a kind of genetic lock-in. Over time, rare traits like Rh negative blood became common, and the average kinship coefficient, a measure of genetic relatedness, rose to 0.12, higher than in almost any other European population. In the hills of Gipuzkoa or the forests of Navarre, families could trace their roots back through the same stone farmhouses for generations. These clues, unusual blood types, tight marriage circles, and the echo of the same surnames hinted that the Basques were not just culturally distinct, but biologically set apart as well. Scientists began to wonder, if these patterns were so strong, what deeper secrets might be hidden in their DNA? In 2018, a team led by Professor Inigo Olalde at Harvard published a genome study that would stun even the most skeptical scientists. For decades, researchers expected to find at least traces of the great Indo-European migrations in Basque DNA, those Bronze Age steppe herders whose arrival transformed the genetic map of Europe. But when Olalde's group sequenced genomes from ancient remains across Iberia and compared them to living Basques, the numbers spoke for themselves. Less than 2% of Basque DNA could be traced to the steppe. In a continent where most populations carry between 40% and 70%, the Basque figures looked like an outlier, almost an error. Yet the results held up, sample after sample, even as colleagues double-checked the data for contamination or hidden artifacts. The implications reached far beyond genetics. The steppe migrations didn't just bring new genes, they brought new languages, cultures, and technologies. In most of Europe, Indo-European tongues replaced local speech, but in the Basque valleys, the language survived. Euskara, already a mystery to linguists, now had a genetic echo. The people who spoke it had barely mixed with the newcomers who swept across the continent. What's more, the study revealed that genetic clusters within the Basque country aligned closely with old dialect boundaries. Villages where people spoke Gipuzkoan or Biscayan dialects showed subtle but distinct DNA signatures, as if the language itself had acted as a barrier, reinforcing the isolation. One marker stood out, R1bDF27, a Y chromosome lineage that dominates Basque male ancestry. This lineage appeared around 4,200 years ago, just as the rest of Iberia was absorbing steppe genes. In the Basque heartland, it took root and stayed, passed from father to son through countless generations. Maps from Olalde's study, when overlaid with dialect regions compiled by linguist Aitor Lacara, revealed a striking overlap. The DNA pools and the language pools mirrored each other, locking in the genetic time capsule that sets the Basques apart. Olalde's findings didn't just answer a question, they rewrote the rules. The Basques had not been left behind by history. They had simply watched the world change around them, holding fast to their own thread in the European tapestry. Today, Basque DNA stands as living proof that Europe's roots are deeper and more complex than any single migration wave. As science rewrites what it means to belong, the Basque story reminds us, true origins are rarely simple, and some mysteries endure because they are written in us all.